thermochemistry experiment. As we all know that in thermochemistry we study the measurement of amount of heat evolved or absorbed. Our aim of neutralization of strong acid, that is 0.5 molar HCl, and strong base, that is 0.5 molar NaOH. Now, the heat or enthalpy of neutralization is the heat evolved when an acid and a base react to form salt and water. Okay, now the heat enthalpy of neutralization, that is also called as the heat of neutralization. It is an enthalpy change when 1 mole of H plus ion of an acid is completely neutralized by 1 mole of OH ion of a base to form 1 mole of water. Now, the heat of neutralization of any strong acid and strong base is always constant. Okay, why? Because due to the complete dissociation of strong acid and strong base, and it will always come out to be constant, that is delta H equals to minus 57.3 kilojoule. Now if you see the reaction here, we are taking strong acid, that is NaOH. So this NaOH reacts with HCl to form NaCl, that is sodium chloride, and water. So यहाँ पर जो H2O बन रहा है, 1 मोल ऑफ H2O बनने के लिए यहाँ पे जो the reaction is exothermic. Negative sign क्या बताता है? Here it is bond formation takes place and there is a release of energy. So delta H will be equals to minus 57.3 kilojoule. In case of weak acids and strong bases, the enthalpy of neutralization is less than that of the strong acid, and strong base as same heat is utilized for complete ionization of the weak acid. ठीक है, क्योंकि जब वीक एसिड ब्रेक होगा, क्योंकि वो कम्प्लीटली डिसोशिएट नहीं होता है ना, तो उसको क्या करना पड़ता है, तो यहाँ से जो हमारा हीट रिलीज हो रहा है उसमें से कुछ हीट वहाँ पे बॉन्ड ब्रेकिंग में यूज़ हो जाता है एसिटिक एसिड में, क्योंकि वो कम्प्लीटली डिसोशिएट नहीं होता है. Is that clear? Let us see what all apparatus we will be using for this experiment. We will take polythene bottle with a cap that has a hole for inserting thermometer. Okay. We will take laboratory thermometer, water in a beaker. Okay. Measuring cylinder, 0.5 molar HCl and 0.5 molar NaOH. Okay, and filter paper to wipe out the thermometer. Now let us see the procedure. We will take 50 ml of 0.5 molar HCl in a clean and dry polythene bottle. Now we will record the initial temperature, which is 1 degree Celsius. Now we will wash the thermometer with water and gently wipe it with the filter paper. Now 50 ml of 0.5 molar NaOH is taken in a clean dry beaker, and we will record the initial temperature T2 degrees Celsius. Now we will add this NaOH solution to the polythene bottle and shake well. Then we will record the constant maximum temperature of the mixture, that is T4 degree Celsius. Let us start with our procedure. ओके, यहाँ पर हम लोग ने क्या किया है 0.5 मोलार HCl that we have taken 50 ml. ओके, फर्स्ट वी विल टेक पॉलीथीन बॉटल, अच्छे से वॉश करके ड्राई करके लेना है. उसके बाद 0.5 मोलार जो HCl है हमारा, इसको हम लोग इसमें ट्रांसफ़र करेंगे. ओके, after transferring this into the polythene bottle, put the cap and take the initial temperature of this solution. Okay, we will wait for some time and we will see. As you can see here, this will be our initial temperature for HCl. We will wait for some time. Okay, now let us see what is the temperature here. Initial temperature of HCl is 27 degree Celsius. As you can see here, it is 27 degree. Okay, this is the initial temperature of HCl. Now in the second step what we will do, we will take one small beaker. We will take one small beaker here. Okay, now this 0.5 molar NaOH, okay, we will take 50 ml of this, okay, that we will transfer in a small beaker. Okay, this is our 0.5 molar NaOH. Okay, now first we will wash the thermometer. Okay, then wipe it off. Okay, now we will take the temperature of NaOH. Again we will wait for some time. Now we will see the temperature. It is 27.
Solution. When 50 centimeter cubic of 2 molar of sodium hydroxide is added to 50 centimeter cubic of 2 molar hydrochloric acid in a plastic bottle, the temperature rises by 13.57 degrees Celsius. Find the heat of reaction for the reaction in kilojoule per mole. The first step is to calculate the heat change. In the formula of heat change, M equal to the total mass of solution, in this case hydrochloric acid solution, and sodium hydroxide solution. C is the specific heat capacity of solution, which equal to 4.2, and theta equal temperature change. In this example, the heat change is defined as 5,700 joules. Second step is to calculate the number of moles of each of the reactant, hydrogen ion and hydroxide ion. Next, write down the ionic equation. Lastly, link the number of moles of the reactants with the heat change, and calculate the heat of reaction. In this case, 0.1 mole of hydrogen ion reacts with 0.1 mole of hydroxide ion, to produce 5,700 joules of heat. Therefore, 1 mole of hydrogen ion reacts with 1 mole of hydroxide ion, to produce 57 kilojoules of heat. Since this is an exothermic reaction, the heat of neutralization between hydrochloric acid and sodium hydroxide solution is negative 57 kilojoules per mole. The figure shows energy level diagram for the neutralization reaction between hydrochloric acid and sodium hydroxide solution.
तो आप हमें नीचे कमेंट में जरूर बताएं ताकि हम आपकी परेशानी को जल्द से जल्द दूर कर सकें। अगर आपको हमारी वीडियो पसंद आई हो तो इसे लाइक करें और ज्यादा से ज्यादा शेयर करें ताकि बाकी लोगों तक भी ये जानकारी पहुंच सके। हमारे चैनल को सब्सक्राइब करना बिल्कुल ना भूलें और हमारी वीडियोस को सबसे पहले देखने के लिए बेल आइकन को भी जरूर प्रेस करें।